Good afternoon. Welcome to the webinar, Why Your ATP Test May Not Be Working, the Impact on Your Environmental Monitoring Program. This event, brought to you by Food Safety Magazine, is sponsored by KIKKKOMAN. I'm your moderator, Barbara Van Renterhem, Editorial Director of the magazine. Thanks for joining us. Today's presenters are Mikio Bake, Planning and Development at KIKKKOMAN Biochemica Company, Tom Boudreau, Market Specialist at Weber Scientific, and Asif Rahman, Sales Manager at Weber Scientific. The agenda for today's webinar is as follows. Our speakers will first define ATP, or adenosine triphosphate, describe the new research on the weaknesses of ATP and how this impacts the food industry, how these problems can be solved, and how your environmental monitoring program can benefit, and then they'll finish up with a description of some successful applications. Please take the time to submit your questions during the presentation. At the end of the program, our presenters will address as many of your questions as possible. Today's event is being recorded and will be archived on our website, foodsafetymagazine.com. And now I'd like to turn today's webinar over to Dr. Mikio Bake, joining us from KIKKKOMAN's Tokyo headquarters.
Hello everyone, my name is Mikio from KIKKKOMAN. In the first part, I will explain the weakness of ATP tests and what is A3 test that can overcome the problem. I will talk for about 15 minutes. First, let me introduce KIKKKOMAN. Do you know KIKKKOMAN soy sauce? KIKKKOMAN continues soy sauce business for more than 100 years. We have soy sauce factories in US, 2 factories, Wisconsin and California. Actually, I worked for KIKKKOMAN US laboratory in Wisconsin-Madison for 3 years. By the way, KIKKKOMAN also has a biochemical business based on our brewing and enzyme technology. One of our major products in our biochemical business is food safety and hygiene monitoring tests. Regarding today's topic, KIKKKOMAN has been in ATP test business for more than 20 years. We are one of the largest ATP suppliers in the world. Many people wonder why KIKKKOMAN is in this business. KIKKKOMAN is also a food and beverage manufacturer. So we are very interested in hygiene management like you and developed our products that we want to use. Moreover, we can produce key enzymes in our biochemical factory. Let's start main subject. What is ATP? ATP is abbreviated name of adenosine triphosphate. It is a universal energy molecule that is found in all living things. For example, ATP can be found in microorganisms and food residues. Therefore, ATP is a good indicator of sanitation and cleaning efficacy. However, there is a weakness of monitoring using the conventional ATP tests. ATP can be degraded to adenosine diphosphate called ADP and adenosine monophosphate called AMP by heat, acid, alkaline, and enzymes. It is known that ATP dramatically degrades in many foods. Recently, the researcher from the University of Wisconsin-Madison demonstrated a very interesting data about the changes in ATP concentrations in raw meats. They monitored ATP, ADP, and AMP in raw beef, pork, and chicken. Vertical axis is logarithmic scale of adenylate concentration. Horizontal axis is time after slaughter. The orange lines are the concentration of ATP concentration. The gray is ADP, yellow is AMP. The blue lines are the total adenylates, 3 adenylates, that is ATP plus ADP plus AMP, that we name A3. In raw meat samples, ATP is predominant adenylate at initial stages, but it is shown to degrade dramatically. ADP is stable and becomes a predominant adenylate over time. As a result, these data indicate that the conventional ATP test can miss the raw meat residues after insufficient cleaning because it can detect only ATP but not ADP. On the other hand, the concentration of A3 is more stable and looks more reliable of cleaning, indicator of cleaning, than using ATP alone. In order to overcome the weakness of the conventional ATP test, we developed the device for the simultaneous detection of these 3 adenylates using our original enzyme technology. Here is the principle of the A3 assay. Firefly luciferase can produce light using luciferin and ATP, which is converted to AMP. Then, successively, ATP can be quantified by the detection of light, and this is well known as conventional ATP test. KIKKKOMAN improved this test using our expertise in enzyme chemistry. We added 2 enzymatic reactions. ADP is converted to ATP by pyruvate kinase reaction, and AMP is recycled to ATP using pyruvate orthophosphate dikinase. As a result, we successfully established the A3 assay method. In food industry, monitoring food residues are very important for the prevention of foodborne illness. For example, raw meat, fishes, and fresh vegetables can contain pathogens. Food residues can also become a source of nutrition for microbial growth and barrier for the bacteria. As a result, food residues can assist in the formation of biofilms. Moreover, food residues can also contain allergens. Therefore, food residues should be controlled by cleaning and sanitation and monitored carefully by hygiene monitoring. We compared the signals of A3 test and ATP test for various foods that was homogenized and diluted with water. The unit of measurement values is relative light units, RLU. ATP can be detected in milk and orange to some extent, but A3 can be detected with higher sensitivity. Regarding other 6 foods, raw chicken, sausage, canned tuna, raw shrimp, peanuts, and beer, very little ATP was present. On the other hand, the signals of A3 tests were significant. All detections were more than 2 orders magnitude greater in sensitivity than ATP alone. I would now like to show you a video demonstration of this phenomenon. Let's start the video. The bratwurst are scrubbed on the stainless steel coupon. The coupon is swabbed using 3 swabs simultaneously, and the 2 conventional ATP tests and KIKKKOMAN A3 test. The swabs were returned to the main bodies, and the reagents were mixed, and measurements were started. The center is KIKKKOMAN A3 test. Left and right are conventional ATP test. Of course, they must show high measurement values because there is no cleaning. A3 test shows 160,000. On the other hand, conventional ATP test shows just 5 and 19, indicating passing result and completely missing the lack of cleaning. To illustrate this in another experiment, this slide shows the comparison data of swabbing assay on stainless steel coupons between ATP test and A3 test. The coupons were exposed to raw chicken meat. This time, however, the plate was washed 4 times. The first wash is simple rinse with cold water. The second wash was simple rinse with hot water. In the last, the plate was cleaned using sponge with detergent and rinse. After each wash, ATP test and A3 test were carried out. Regarding the ATP assay, as shown as red line, the first and second wash with just cold water and hot water produced less than 200 RLU, that is typical passing benchmark value. That is, the ATP test indicates that the surface was clean enough, although the cleaning was obviously not adequate. On the other hand, the using A3 assay, as shown as green line, 200 RLU action levels was not achieved until after complete washing with detergent and rinse. This result shows that the A3 test is more reliable indicator of surface cleaning and sanitation. This is all for my presentation. I look forward to any questions at the end. Thank you very much for your attention. I would now like to introduce Tom from Weber Scientific. He is going to discuss the case study on craft beer brewing company. Tom.
Okay. Thank you very much, Mikio. I wanted to move on to the next portion of the presentation to discuss a little bit more about a case study on the application of A3 technology to improve overall sanitation in a production environment. As Mikio mentioned, I'm Tom Boudreau. I'm the market specialist at